as highly mathematical students doing mathematics since secondary school till date, done a lot of mathematics, you should know that once you hear that something is equal to something, it means that if I carry this and come here, carry this one and come here, it means the same thing. So let's prove it. And we know that what this thing is simply talking about, everything here is simply electric flux. Well, this is what electric flux is. Then Gauss theorem now said that it is equals to Q over E naught. That is the total electric, that is the total charge all over permittivity of free space. So let's try to prove it. So to prove it is simply saying E on its own, which is electric field of at a point, the electric field of a point charge. The electric field of a point charge is given by KQ all over R square. You need to note it. This is that formula we normally give for electric field intensity. So note it, write it somewhere that electric field, I said that electric field of a point charge, I did not say of lines of charge, maybe in cylindrical or conducting line or infinite sheet or infinite line. I said point charge, just one. That is a charge that is flowing out, moving out, and the one that is receiving maybe negative charge is the electric field there is given by KQ all over R square. Now, if this is the point charge, you remember I told you in our first class that by the time you check all the things pointing outwards, pointing outward, pointing outward, pointing outward, and let's say you form a Gaussian surface for this, it is more like it's taking the shape of a sphere. It's taking the shape of a sphere. So if I know that, that means you can always see it as in this way. The earth is spherical, is it not? So charges are on this are considered using the surface of the earth. If it's best for you, you put it that way. So the area I'm going to be using here, which is A, that is area of Gaussian surface for point charge, is simply 4 pi r square, which is the area of a sphere. You need to note this. I said that area of Gaussian surface for point charge, area of point charge, area of Gaussian surface for point charge is 4 pi r square. That is when you differentiate volume of a sphere, you get the area. So you have it there. Now we need to remember from still here, I'm trying to prove that this is equals to this. So if I have this, remember that K from our first class, we said that K is equals to 1 over 4 pi epsilon naught, or 1 over 4 pi epsilon, that is permittivity, whichever way you use it. So let's put it 1 over 4 pi epsilon naught. Now, everything here times Q, then divided by R square, then times 4 pi r square. So I just replaced K, put Q, put R square. Now notice that if this is the case, I will now have Q 4 pi r square all over 4 pi epsilon naught divided by r square. Anything not standing on this one is over 1. So if I do this, you now see that 4 will take care of 4, pi will take care of pi, is it not? Remember I still have Q here. So if I do this way, I now have, then notice something. R square will take care of R. Okay, but I've not gotten there. Let me not do R square for now. Let me just, so I will now have Q R square all over E naught divided by R square. Remember I said let's not divide this one now. R square over 1. So times 1 over R square. See that this can take care of this. So that I now have that everything on EA is now equals to Q over E naught. So are you seeing it? So proved. I write it this way. So that means that EA is equals to Q over E naught. Thank you. Subscribe. Academic Daddy. I love you. Look big things.